Afternoon. We are Group 1STR the Muppets. My name is Cody Metakingi and our chosen design project for the EWB Challenges 5.1. Increase disaster resilience of structures using local materials. This problem was then further specialized to providing shelters which are more effective at mitigating the damage in which storms and cyclones have on the community and shelters, whilst also increasing the resistance that shelters have. Throughout the report, Kyle will evaluate the alternatives, Grant will explain the final design, Andy will identify the design, and Hayden will describe the construction process.
It was clear from the start that option 4 was never going to succeed, as the sandbags more support the house in times of need, rather than making it disaster resistant, which is what the aim of the challenge was to do. Even though this idea seemed economically safe, the actual bag material would need to be purchased outside of the islands, and this would cost a lot to ship in, which wouldn't be worth the effort and labouring involved compared to the options of 1 and 3, which build new structures that have been designed to withstand the severe storms and winds of East Santo. Design option 2 could also be used, except the wind could affect the dirt over time, and this could cause harm to the house as the dirt blows in and causes a mess inside. This is also a very labour intensive structure. Even though the houses are built, the dirt will take ages to stack up and make into a position that best supports the structures. Builder is also one of the design requirements for the design, and this wouldn't be used well in design option 2 as only dirt is being structured onto the house, so design option 1 and 3 are the only two left. Design option 1 requires the house to fold down, and using the materials is another design requirement, but getting these materials that will be able to fold down, which is not bamboo because it cannot bend in any way, will prove very costly to the design, as the house will need to lay flat on the ground to be strapped in to make sure no occupants around the area are injured. And this could become a danger, as people could trip over this if it's not laying down flat. Also, the space that the folded up house takes up on the ground is a bad decision compared to a structure that is standing up straight and tied into the dirt and soil. Design option 2 is the clear winner for the design to be used, as it is locally sourced materials in a way that deflects and tunnels the wind over the house, which will have little to no effect on the structure, while only taking up the normal space of a shelter, and the builders will get paid at labouring wages to ensure that the house are built to the right standard so the occupants are safe when a severe storm hits.
In the design that has been developed, many methods have been chosen to greatly reduce the level of destruction due to storms and aggressive winds, and have been implemented in the final design. One problem that we recognise in the present structures of East Santo is the amount of overhang from the roofs. This increases the level of uplift that the roof is subjected to, so to mitigate this problem, the roof of the structure was placed all the way to the ground. Also, to decrease the wind resistance, the whole structure was submerged into the ground by several centimetres to minimise the surface area of the structure, which is prone to wind resistance. Also, to further mitigate wind resistance, the two lateral sides of the structure are angled at roughly 45 degrees to the ground to maximise the level of wind deflection, as the wind is then directed up and over the house or down into the ground, and thus reducing the risk of the house blown over. The back of the structure is also curved to maintain the 45-degree angle around the rear of the structure to maximise wind deflection and minimise wind resistance. Also, what had to be considered is once the structure is submerged into the ground, it will be prone to flooding when there is heavy rainfall, though to counter this, the floor of the structure will be elevated so that water can be safely passed under it. Similarly, the water that passes under the structure will also increase the level of rotting in the bamboo, though this can easily be fixed by coating the bottoms of the bamboo in a drive-away tar sealer to help seal the bamboo from rotting. Also, a major factor that has been used to mitigate wind resistance is tree placement. After researching the problem, it was found that tree placement is a great way to reduce and manipulate wind direction. This has been taken into account with the designing of the structure, as tree placement has been used to decrease the intensity of the wind is directed at the structure. Though the issue of trees falling has also been addressed, with the trees not being placed within 1.5 of the tree's length away from the structure.
A team has carefully constructed a solution that best fits the current state of East Santos. Vanuatu is currently in a financial crisis by the overwhelming growth rate of the population and not having enough jobs to support this growth. Furthermore, it doesn't make the issue any better by being constantly bombarded with natural disasters. With the effects from past cyclones still in recovery to this day, it sets their economy back even further by using valuable resources to repair these damages. The aim of our design is to prevent this issue from happening, as well as minimizing the damage to the shelters, as well as keeping the people safe and leaving small amounts of recovery as we can from these disasters. When using materials that are locally grown and easily accessible, it makes a great investment for the people, as they won't be repairing as much as they were with their current homes. As our structure is designed to be a lot more weatherproof, as well as being cost effective. Socially, the people of Vanuatu wouldn't have a problem, as most of the materials used within this project is basically the same as their current homes, just built differently. Overall, the structure itself wouldn't harm the environment in any shape or form, as basically all of the structure is made from the environment. And as for sustainability, like I said before, most of the structure is made from the environment, so the materials can be easily replaced. Now I'll hand it over to Hayden, who will be talking about the description of the construction and maintenance costs.
My name is Hayden Chasling, and I will be talking about our construction process for our design. First step is to create the cutout into the ground where a structure is going to be placed. The next step is to implement a raised floor that has bamboo struts going into the ground to get anchored in. Third step is the two side reinforcement pieces for the wall. These are wooden planks with two bamboo beams going into the ground again, getting anchored down. The next step is creating the central support beams. These are two thick wooden beams with a central beam going across the top between the two of them. This is then inserted into the design. Fifth step is to strap chicken wire across the side supports around the curve back and then back down the other side, coming to a point across the two sides. Next step will be applying the bamboo to the chicken wire. The bamboo is dug in half a meter into the ground, tied into the chicken wire as well. The chicken wire is also stapled to the wooden planks, the wooden supports. The bamboo will be tied into the chicken wire, and that goes all the way around again. And then it moves on to the front, the face, which is again bamboo stacked up straight with a cutout for a door. And then we can just use hinges and the handle, and I just put a standard door in there. The last step for this is just the treated grass and ferns that go across around the outside, just to keep the rain off. This overall process shouldn't take any longer than normal construction for their normal houses would. If anything, it should be a bit quicker, especially once they get used to it. The only part that can't be implemented quickly would be the trees, using the trees as a barrier, because they would either, unless they're growing naturally in that area, they'd have to be planted, in which case it would take a very long time for that to grow out. I will now pass it on to Cody for the conclusion.
In conclusion, the design which we have come up with is cheap and affordable, as it is made entirely out of locally sourced materials, which are easily accessible to the villagers. With the building of new shelters, there are also new job opportunities which can help provide villagers with a new way to make some money. Due to the nature of the shelter, the aftermath of a cyclone affecting the village will have a lower economic impact on the community This is because some of the materials will be able to be recycled, and also the materials which are used are all low cost. The shelter will also be less likely to become collateral damage during the duration of the cyclone, as the shelter has been implanted into the ground. Thank you for listening.